Hello everyone, welcome back to the lecture on petrology, rocks and minerals. We're going to continue on talking about what rocks are and how they form. So rocks are just collections of minerals. And so pretty much every rock that you've seen originally formed as bedrock. This is the parent material in which smaller rocks form from. Exposures of bedrock at the surface of the earth without any soil on top of it are called outcrops. And so when that bedrock erodes and forms smaller rocks and begins its process into forming soil, we call that regolith. That's the intermediate process material between bedrock and soil. And so there's three different types of rock besides classic punk and hard. We have igneous rock, metamorphic rock, and sedimentary rock. These are the three different types of rock. And so igneous rock formed from crystallization of magma or lava. So as liquid rock cools, crystallization occurs and forms igneous rock. Metamorphic rock, on the other hand, is rock that has been recrystallized from solid rock due to heat and pressure. It never comes from liquid rock, but instead is formed by a rock being exposed to high pressure and heat. And then lastly, sedimentary rock. So these are rocks formed from cementation of sediment, so small fragments of rock that have been joined together again. And we can see here in this diagram, for example, if we have a plume of magma and that magma cools, it's going to form igneous rock, and it can either erode and form sediments, or it can be exposed to more heat and pressure, therefore forming metamorphic rock, or that sediment can get compacted and cemented into sedimentary rock, and we can go through different cycles between the three different rock types. And we can see here a map that roughly shows where different rock types are distributed on Earth. And we see that Appalachia is generally has a lot of metamorphic rocks, whereas the Great Plains have a lot of sedimentary rocks that have been eroded from other mountain ranges and transported here. And then the Sierras and the Cascades and western states have a lot of igneous rock, generally newer rock compared to other rocks. And so let's start by talking about igneous rocks. So these are rocks that are formed from lava or magma. And remember, lava is liquid rock that's on the surface of the earth, and then magma is liquid rock that's below the surface of the earth. And so there's two different types of igneous rocks. There's extrusive igneous rocks, which are rocks that form at the surface of the earth. They've been extruded to the surface. And then there's intrusive igneous rocks, and these are rocks that cooled more slowly within the Earth's crust and never actually erupted out to the surface. And so we can categorize the rocks based off of how mafic or felsic they are, as well as how intrusive or extrusive they are. And so, for example, we can see here a granite is an intrusive felsic rock, but if it formed at the surface of the earth and cooled more quickly, then it forms rhyolite. And the same for mafic rocks. Gabbro forms slowly inside the Earth's interior, whereas basalt forms on the surface of the Earth. If we take a closer look at granite, it's a great example of an igneous rock, a felsic igneous rock. We can look at the different crystal structure. And so granite is composed of feldspar, plagioclase, which is these white minerals. There's quartz, which is the more gray colored minerals. Feldspar orthoclase, or K-spar, which is the pinkish minerals. and then mica, such as these black biatites. Basalt, on the other hand, is pretty much the opposite type of igneous rock, where granite is a felsic intrusive rock, basalt is a mafic extrusive rock. And as a result, the crystals are significantly smaller, and you're sometimes not able to see them with your naked eye. And it may even have bits of volcanic glass, which is small bits of rocky material that cooled so quickly that no crystals were actually able to form, and it forms a glass instead of a mineral. And so we can go more into the types of structures that igneous formations can form. The most famous maybe is the Yosemite Valley landscape. You can see Half Dome here. It's a beautiful landscape in California formed by intrusive igneous processes. And so it's important to first figure out where all this magma is coming from. And so the large pool of magma underground that forms igneous, intrusive igneous formations is called a batholith. And these big pools of magma can be gigantic. They can cover entire mountain ranges sometimes. And so all of the other formations form out of this batholith. So sometimes the country rock or the parent rock, bits of it break off as this batholith intrudes into the material. And so you have little bits of extraneous rock that get chipped off into this pool of magma. And those bits of rock we call xenoliths. Xeno meaning alien or foreign. So it's a foreign rock to this magma body. And you can see an example of this here. This is an olivine xenolith in a mafic rock. And so it's obviously a different makeup than the rock that's around it. The next formation is a pluton. So a pluton is a bubble of magma in the Earth's crust that comes up and forms a bulbous structure. The most famous example of which is Half Dome, which this dome-shaped rock formed as it bubbled up from the batholith and then eventually eroded away and had a glacier shear off half of it, leaving Half Dome. And so the next type of structure that we're going to talk about are dikes. So dikes are vertical sheets of magma that cut through the rock layer. So you can see that here is a diagram showing a dike in this sheet-like formation. So you can see here this is the parent material, and the dike comes up from the batholith or maybe a pluton, and it cuts through vertically through these layers. On the other hand, a sill cuts into the parent material horizontally. So it is it follows the bedding, the layers of the rock, and it kind of inserts itself that way instead of cutting through into them. And then a laccolith is just a particularly thick sill, a sill that's gotten so much magma pumped into it that it bulges out and it deforms the rock above it, and it forms this lens shape. This mountain here is formed as a laccolith. And then we also have volcanic pipes. So sometimes this magma ends up reaching the surface, and it often does that through a volcanic pipe. So it's a vertical column of magma that reaches the Earth's crust. And you can see an example here where you have this pipe that's made it up to the surface and this sill or this dike coming off of it. So next, let's talk about extrusive igneous rocks, the most notable of which are volcanoes, where you have magma coming up and releasing lava all around them. So there are multiple different types of volcanoes. The first of which, the least explosive of which, are fissure volcanoes. So these are volcanoes that form as an area of land gets stretched and extended, much like as we talked about previously, mid-Atlantic ridges, where you have two plates moving apart. You would have magma coming up from the upper mantle and filling this fissure volcano. They tend to be relatively benign, given that it has magma coming up. But yeah, they form these linear structures as well. The next type of volcano is a shield volcano. So shield volcanoes, like this one in Hawaii, pretty much the entire island of Hawaii is a shield volcano, form very broad mountains. They're very low slope and they can extend out very far. And so the reason for this is because the lava that comes out of them has a very low viscosity relative to other lavas. And so it can flow a very far distance before it actually cools and forms a rock. And so because of that, you have that lava more easily spreading out, and so the slope of the mountain tends to be really low. Next, we have cinder cones. So cinder cones are really cool if you ever get to see one. They're dotted all over the western United States. But they're formed from cinder, which is small pebbles of volcanic exstrata that come out and form these small domes. And you can see this is an example of cinder here. It's this kind of aerated volcanic material that comes out, and it rolls down the mountainside and it forms this cinder cone with kind of a close to 45-degree slope. Larger than that, we have stratovolcanoes or composite volcanoes. And these are called composite volcanoes because they're made up of multiple layers. So you have a combination of layers of lava flow, so that's lava that comes up and then extruded as liquid and then cools, as well as tephra, so that's solid material that gets extruded out and blown off. And so it'll cool within the volcanic pipe and then burst out. So you have these multiple layers of lava flows and tephra on top of each other, forming this volcano. Next, we have dome volcanoes, and we're starting to get into very large, very explosive volcanoes. So generally, shield volcanoes tend to have very felsic lava, and therefore they have a low viscosity, whereas dome volcanoes have very, shield volcanoes have very mafic lava, and so they have a low viscosity, whereas dome volcanoes have very felsic lava, and therefore it's much more explosive. So a lot of times that low viscosity of the lava can kind of plug it up, and therefore in order for the lava to come out, then you need an explosion. And this is Mount St. Helens, which is a very famous volcanic explosion that happened in Oregon and exploded material all over the Pacific Northwest. And then the largest of volcanoes are called calderas. These are volcanoes that can cover entire regions, and they have their centers that have completely collapsed as magma flows up into them. And so these have caused some of the largest volcano eruptions on Earth, including the Yosemite caldera, which, when it erupted, released ash all the way down to Florida and New Jersey as well, where we had ash being deposited. And so these are extremely explosive, although they don't have a lot of lava or eruptions coming up very often. So we can classify different material that comes out of a volcano based off of its size. So we call very large rocks that come out that form boulders, we call these bombs, pyroclastic bombs. Whereas smaller material that's more pebble sized, we call lapilli. And so you might see lapilli scattered all around a volcano, as well as less frequently these large bombs that can cause a lot of damage. Another feature of volcanoes that can be extremely dangerous are lahars, and we'll watch this video now to get a sense of what they are.
Major danger on many volcanoes comes from floods of water mixed with volcanic debris. These floods are called lahars. Lahars are more destructive than a normal flood because they contain large amounts of rock, ash, and mud and debris. Boulders swept along by the lahar can sometimes be the size of a car. They can form very quickly and flow down the volcano into the surrounding valleys, often at high speeds. Several lahars often occur in quick succession. Lahars are a major cause of death in volcanic eruptions. They can travel great distances, many kilometers or even many tens of kilometers, so communities far from the volcano can still be in great danger. There are many causes of lahars. A very common cause is if there is heavy rain. An eruption can cover the sides of a volcano with loose rocks and ash. Vegetation and soil, which normally absorb the rain and prevents floods, can be destroyed by the eruption, adding to the problem. When it rains heavily, rock, ash and debris are easily swept into the water, forming lahars. The rocks and debris give the lahar extra destructive energy, and often the flows move much faster than someone can run. Some volcanoes are covered in glaciers and ice or snow. Eruptions of hot rocks can melt the ice or snow rapidly to form bursts of huge volumes of water that form lahars.
Yeah, so whenever you have a volcanic eruption that's associated with a lot of rainfall or snow melting, then you can have lahars, which can be very dangerous. And we'll watch a couple videos to give you some perspective of how destructive
major
these can be.
Tu peux te pousser, monter un tout petit peu s'il te plaît?
Yeah, so a lot of times boulders the size of cars can be moved, and they can knock entire houses down. So one of the major reasons for injury and death associated with volcanoes, besides the lava that erupts and the ash that is deposited, is also lahars. Next, we have pillows, maybe a lighter subject. So pillows or pillow basalts are extrusive igneous rocks that form underwater. So whenever lava is extruded out underwater, then it can form pillows. And the cause of this is that when you have lava going into the water, it cools very rapidly. But it still wants to keep flowing out, so it'll form a crack, and then it'll spew out and form a bulge again that will cool, and it continually forms these bulges outwards. Next, we have pillar basalts, which are very cool features if you ever get the chance to see them. This is in Iceland and in California, where you have pillar basalts form. And so these are basalts, an extrusive igneous rock, that have regular fracture planes. And they form this hexagonal structure as it cools and contrasts. The rock is very hot, and as it cools, it decreases its volume, and these cracks develop in a regular pattern. So a lot of the terms that we have for lava and extrusive features come from Hawaiian. So pahoho and a'a lava are two of those terms. So pahoho is lava that forms this rope-like structure that's kind of forms this smooth like feature on the surface, whereas a'a lava, if you were to walk on it, you would say a'a, it would feel very rough because the air within the lava has formed these sharp edges as it flows. Then the last extrusive rock formation that we're going to talk about is pumice. So pumice, you might have used it on your skin before, is a type of volcanic rock that forms because there's just so much air dissolved in that rock and air bubbles that form as the rock cools that it's actually lighter than water. It's the only rock on Earth that can float. So it's a very cool rock just because lavas can have a lot of gas, carbon dioxide and oxygen and other gases dissolved within them. So next we're going to talk about sedimentary rocks, but first let's take a short break, and I'll see you guys in the next video.